In this lesson, we will continue on Maclaurin's expansion, and this time around we'll take a look at triangles, small angle approximations, and some trigonometry. So first up, in this question from HCI Prelim 2016, in a triangle ABC, AB is x cm long, or rather x units long, BC is y units long, AC is 1 over 6 units long. ABC is pi over 6, ACB is theta radians. Show that x over y is equals to this fraction over here. For this part, you should realize that you don't have to use any differentiation, Maclaurin's integration, or whatsoever. You just need to apply basic trigonometry you learn in E-math in Sec 3. So here, this is a clear case of sine rule, I believe. So let's apply sine rule here. 1 over 6 over sine pi over 6 equals to x over sine theta, and is equals to y over sine. Now what is this? This would be pi minus pi over 6 minus theta, which would give you 5 pi over 6 minus theta. So here is y over sine 5 pi over 6 minus theta. Clearly, we got to use these two. We will not be using this for now. So let's take a closer look on how we use this two. X over sine theta equals to y over sine 5 pi over 6 minus theta. So divide both sides by y and multiply both sides by sine theta should get us this. All we need to do is apply addition formula for the denominator. We should get sine theta sine 5 pi over 6 cosine theta minus the other way around, cosine 5 pi over 6 sine theta, which would give you sine 5 pi over 6 is the same as sine pi over 6, which will give you half cos theta. Cosine 5 pi over 6 is the same as negative cosine pi over 6, which would give you negative root 3 over 2. So minus gives you plus root 3 over 2 sine theta. Multiply your numerator by 2 and your denominator by 2. 2 sine theta over cos theta plus root 3 sine theta. And we are done for the first part. So for question part 2, given that theta is sufficiently small, express x over y as a cubic polynomial in theta. So we gotta expand all the way until theta cube. Everything that has theta cube is important. So first of all, let's recall our small angle approximation here. Sine theta approximately equals to theta, cosine theta approximates to 1 minus theta square over 2. However, because they want to go until theta cube, the next item here is actually a theta power 4, so there's no need for that. For sine theta, you actually have to have the next term because that has a theta cube in it. So you will need this minus theta cube over 3 factorial 6. Every time we see a sine and we see a cosine, we just replace accordingly. Therefore, x over y would give us 2. Sine theta will give us theta minus theta cube over 6. Divided by cosine theta give us 1 minus theta square over 2 plus root 3 theta minus theta cube over 6. Let's clean this up and let's turn this into a non-fraction. We should give us 2 theta minus theta cube over 6 multiply by 1 plus root 3 theta minus theta square over 2 minus root 3 over 6 theta cube to the power of negative 1. Now we're going to make use of binomial expansion. I've copied down the formula here. So think of this entire thing here as your x. And then we'll just expand accordingly. So let's see what we'll get. Now you have to expand strategically because most of the stuff is not needed. So this is on the outside, 2 theta minus theta 3 over 3 multiply by, first thing, 1 plus nx. So you get negative root 3 theta minus theta square over 2 minus root 3 over 6 theta cube. Actually, this is not even needed because if you want to get to theta cube, there is a theta in front. It's going to multiply by everything. So you don't need this. So we're going to stop here and then move on to the next term. The next term will be n times n minus 1 over 2 factorial, n times n minus 1 over 2 factorial. 2 over 2 gives us just 1. So plus x squared. How many of these are actually needed? Technically, only the first item square is needed because everything else will give us power that are too huge. We don't require them. So the only thing that you need here is 3 liter squared. So now let's just expand strategically and figure out what's needed and what's not needed. First of all, the first item, 1, multiply by this. This is needed. This is also needed. So let's write them both in. Equals to 2 liter minus liter cubed over 3. So now let's take a look at the second set. This times this. Is this needed? Yes, because it gives us power 2. Is this needed? Yes, it gives us power 3. Power 4 not needed. Power 5 not needed. So let's just write these two down. Minus 2 root 3 liter square. 2 liter times negative negative positive plus liter cube. And then finally, this and this, the only thing that's required is this one. Last term, plus 6 liter cube. Add them all up, I should get 2 liter minus 2 root 3 liter square. 6 plus 1, 7. 7 minus 1/3, which will give us 20 over 3 liter cube. Final part of this question, part B. First part, show theta is equal to sine inverse 3x. There is one item that we have not used yet because this 1 over 6 at the very beginning, you realize that we did not use this. So now, of course, I believe we have to sort of use this. If not, they give for what, right? So this is 1 over 6. So let's just use this and see how we can do B part 1. X and theta, 1 over 6 and pi over 6. Once again, I believe we're going to use trigonometry sine rule. X over sine theta is equals to 1 over 6 over sine pi over 6. Sine pi over 6 would just give us half. So 1 over 6 divided by half would give us 1 over 3. Cross multiply, we get sine theta equals to 3x. Theta is equals to sine inverse 3x. You should tell by the amount of marks that's awarded how difficult it is. 1 mark shouldn't be too much of a hassle. Once we've done this, find the Maclaurin's expansion for theta up to and including x cubed. Expand this using Maclaurin's, and we do f0, f prime 0, f prime prime 0, f prime 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 0. Now it will be pretty horrible to straight away differentiate, meaning to straight away find d theta dx, because you will get some kind of fraction here with a square root, because that's the differentiation of sine inverse. And then further differentiation will create a huge mess. So we do not do that. What we do, the technical way, would be to apply sine inverse to this side. So we will give us sine theta equals to 3x, which is in fact the step before what they want you to show. From here, it's easier to do implicit differentiation. Differentiating this whole thing implicitly with respect to x will give us cosine theta d theta dx equals to 3. That's stage 1 done. Stage 2, hold cosine, differentiate this. So we get cosine theta d2 theta dx square plus hold this, differentiate cosine theta theta dx negative sine theta d theta dx. This time round, right hand side just gives you 0. If you were to clean this up, you will get square. We're done with the second stage. Third stage is rather long. 2 items here. Product rule, hold 1, differentiate this, plus hold this one, differentiate this. Differentiate this gives us negative sine theta d theta dx. Second pair, this and this. You will get hold this, differentiate this, plus hold this, differentiate this, power minus 1, followed by differentiation of the inside, and then the right hand side equals to 0. So let's just go back and unravel these values. When x is 0, theta is 0. So the first level is just 0. Second level, when x is 0 and theta equals to 0, d theta dx, this will give you 1. So d theta dx is just 3. Next stage, the green one, here f prime prime 0. So every time we see a theta, we put 0. This will give you 1. This is the one we want to find. This will give us 3. This will give us sine 0. So this is actually redundant. So d2 theta dx square gives us 0 as well. And next, the last and final stage, here, this will be 1. This is the one we want to find. This will give us 0, so this is redundant. This will give us 3 square. This is also 3, so this is 27. This is negative 27. This is sine theta, so this thing is gone as well. So 1 times d3 d theta dx, sorry, this is a cube, would give us 27. Arrange this using the Maclaurin's expansion, should give us fx equals to 0 plus 3x plus, now 0 is gone, so that there's no x squared term. Next term would be 27 over 3 factorial x cubed, and so on. Simplifying this will give us 3x plus 9 over 2x cubed, and so on. That's it for this question.